Hello.
Hi, everyone. Let's wait just a couple seconds so people are joining this webinar. So the numbers are getting up with people joining. Okay, I think we can start, right, Sonia? Do you feel
Yes,
likely?
go ahead.
Okay. Okay, so welcome everyone to a new online event. This is this online event is belong to the series from Fundación Innovación Bank Inter. My name is Marta Cancho, and today we have the opportunity to explore an exciting field that it is transforming our daily lives, which is physical artificial intelligence, or what we used to call embodied AI. In this session, we will discuss our most recent report, Physical AI, that had been discussed 1 year ago, actually. No, in December, sorry. I was, my mind blow out. So this document brings together contributions from more than 40 international experts who participated in the latest Future Trends Forum, an space dedicated to analyzing the impact of the most disruptive technological advances. On this occasion, the report focuses on how artificial intelligence, when applied to the physical world, is redefining the interaction between humans and machines. Today, we have an special guest, Sonia Chernova, who is a researcher and professor at the Georgia Institute of Technology. And she has specialized in robotics and human-robot interaction. So, Sonia, welcome to a new forum. Welcome to a new event of our Bank Inter Innovation Foundation, and thank you so much.
Thank you so much for having me, and thank you all for attending. So I'm going to go ahead and share my slides in a second. I just want to preface that by saying that the report that was mentioned covers a lot of different topics from many experts. A lot of what I'll be talking about is synergistic with that and covering the foundations of robotics and where we have been and where we're going. And I'm very much welcome questions. So if you have questions, please ask. Of course, I'll leave time at the end for questions, but for now, I'll just start with some information. So here we go. You should be able to see that slide. And so I'm faculty. I do research. I teach at an American university called Georgia Tech, and it has one of the leading AI and robotics programs. And what I want to talk about today is just all kinds of different robots. And the way I'm going to structure my content here is to use this lovely summary that has been put together by some of the venture community. They're credited at the bottom. That talks about the different waves of adoption or different stages of development of what we call embodied AI or robotics, whatever term you want to use. I prefer robotics personally, but embodied AI makes a lot of sense as well. And so we'll talk about these as we go. I'm going to spend more time on the current stuff, of course, but I want to go slowly just because it's really important to understand the context of where we are by understanding where we came from. So let me start with, very traditional, what we would call, at this point, old robots, right? This was in the 80s, 90s when we really saw the adoption of robots. And I just have one picture I want to show for that, which is this. And I think this picture captures those types of systems. These were very large, heavy machines, very high power, high voltage. If you pay attention, right, there's a wall here. There's a mesh wall. People are not allowed in this space. These robots are very fast. They're incredibly precise, which is wonderful. They spurred entire, new innovations in car manufacturing and everything else. but they were very complicated to run and remain complicated. Many of them are still operating. They require specialized software and training, specialized engineers. And the biggest factor was you had to design a factory around them. You couldn't put people in the same space. They weren't movable by any means. They're very, very heavy. So this is where we were in the 80s and 90s. And that's all I really want to say, other than to say that, okay, we've changed. The world has really changed. So let's look at what happened in the first, 15 to 20 years of this century. What happens roughly since the year 2000? And a lot of my conversation here will focus on still manufacturing, but also logistics, because those were the big success stories of that time period. And if we're going to look at robot arms, like I did, just to contrast this with the previous picture, what you see now for robot arms compared to those giant industrial ones are what we call cobots. So if you're not familiar with the term, it's quite important in robotics. Cobots just means collaborative robots. And these are still robot arms, but as you can see, that people can be right up close to them. They can touch the robots. They can push the robots around. They can teach them. Here, I'll show you a quick video.
Satisfying the need and requirement.
Oh, I don't want the audio. But you can see these robots are doing all kinds of tasks, and people are right there with them. All right, there's a person right next to it. This robot's going to apply what looks like solder or glue, fetch materials for a worker, whatever it is. And so really just changing the paradigm of how we view robots, right? Instead of people in one place and robots in another, we're bringing them together. And this type of product, a cobot, is available from pretty much every major robotics manufacturer that produces robot arms. So European companies, Asian companies, US companies. Now, they're smaller, that they don't entirely replace all the big things, right? We still need big robots for giant car parts or something else. But for many, many manufacturing logistics tasks, picking and what we call picking things up and moving it, these work really well because they have a payload. The bigger ones are probably close to 15 kilos, which is not bad for most things. They have a smaller reach, about 1.5 meters most. Most of what they do is much closer than that. So if you need a bigger reach and you need a bigger robot, you're going to have to move to something bigger, a little bit more traditional, a little bit more dangerous, likely will need to be caged. But for smaller tasks, we have cobots. And this has been a huge innovation, right, in kind of the mid to early 2000s. At the same time as this was happening, we also developed more and more intelligent navigation platforms. So what are called AMRs, autonomous mobile robots. And so we see more and more warehouses and logistics operations where people don't have to walk long distances, but instead use small transport vehicles like this to carry packages on the left, or on the right, it's showing that the robot can actually lift an entire shelf unit and bring the shelf to the person, right? So there's many different variants of these technologies, but all of them integrate nicely within current warehouses, current distribution centers. You don't have to change a lot. They can drive around other people, around vehicles, and they save a lot of time and effort, and they self-charge and so on. And here's a quick example of one. This is a pharmacy or pharmaceutical company. They process medications, and this is a video of some of their robots. And again, what we see is that the warehouse becomes a little bit more empty of people. Some people are still here putting things on and off. But for the most part, it's saving them a lot of time walking around, carrying things, and makes all operations much more efficient. Now this is not limited to just warehouses. There we go. You might have seen this type of robot. This is Starship, right? This was started in 2014. by the founders of Skype. Originally, I think they were headquartered in Estonia, and now they're headquartered in the US, but operate out of Europe. It says that my university has these delivering food, these robots delivering food all over campus right now. So we also have, of course, street robots. Now, you might be starting, well, I'll point this out in a little bit, but please note that I've shown you arms, robot arms, and I've shown you things that drive. And I'm not showing you anything that does both. And there's a reason for that, because that's a lot harder. So we'll come back to that. Now we can go bigger, right? And I've shown you everything that's pretty small. We can go much bigger. This is one of the many autonomous forklift operators. This is Fox. But there are many companies similar to this. I like this video because it shows off the size of the sensors, kind of gives you an idea of what's happening. And these are autonomous forklifts that just move pallets of goods in warehouses. And they can fast forward a little bit, because they basically keep going and going and going, and lots of boxes are being moved by these fairly large, heavy, and fairly dangerous equipment. So the safety record on these is very high. All right, so we've been working our way through what I would call logistics, right? Logistics, warehouse automation, distribution centers, and that's been the success story of robotics in many ways for the last 20 years, and it continues to be. The technology, some of the companies that I'm showing you, I'll actually show you 3 more in a second, were all started in that period. So what have we talked about? We've talked autonomous forklifts for loading and unloading trucks, right? We've talked about robots that move shelves. We've talked about robot arms that maybe pack or unpack boxes, or move boxes from one conveyor belt to another, things like that. The one thing I also want to highlight on the logistics side is this kind of setup. And this is called automated storage and retrieval. And this is a different type of embodied AI, very different type of robot, where the entire environment is changed. So with all the earlier ones I've shown you, we've tried to keep the warehouse more or less the same and just add the robot to work alongside workers, make workers more effective, but without really requiring a complete change of the warehouse itself. So now let's take that assumption and sort of throw it out the window.
So why waste time on shelf-based solutions when AutoStore is here? AutoStore is a cube-based system, making use of all space for proper warehousing. Turn that wasteful air into storage and double, triple, or even quadruple the inventory capacity without moving to a new building.
All right, so I'm going to mute the audio now, but this is the idea of why these kinds of solutions are practical, is because of space efficiency. With the same amount of land, you're able to roughly triple or quadruple the amount of product that's being processed and potentially the rate of that product. So AutoStore was started in 1996, I believe, in Norway. And they're using a vertical system of stacked boxes and these simple robots that lower and raise boxes within these bins. And of course, one limitation of AutoStore, of this particular solution, is that it can only handle smaller objects. But you can imagine other solutions that could focus on larger items, and I'll show you that in a second. Before we do that, I want to show you another company that you may be familiar with. That's Ocado out of the UK, founded in the year 2000. So again, you kind of get a sense of when things were founded. And it probably took us, most of us, another 10 years before we really heard of the company, from its founding to when their product was mature and actually useful and practical. But I'll go back for a second. This is groceries, right? So they're doing the same type of grid layout, but they're automating the fetching and delivery of grocery orders. And many of us know, right, we can now sometimes order food online. have it delivered, and that's part of what they do. They can service entire grocery stores as well. And then going back to the warehouse, this is a video from a company called Symbotic, which was founded in 2007 in the US. They are currently in the process of automating all of Walmart for the US, which is our largest store group. And the reason I wanted to show this one is, unlike the previous examples, which were very rigid in terms of bins and structure and really requiring this grid, Symbotic is a little bit different. They build about 9 to 10 floors of shelving, but they store all kinds of boxes in those shelving. They don't use special boxes, they just use the products themselves. So you can see here that there's some diapers, there's some coffee, there's some shampoo, all of them within these walls. I've actually been to either this center or one of the other ones in this video. It's really very impressive how they handle this. And so that's just the storage. I want to show you part 2 of this video. So when this is how they automate distribution centers. So distribution center handles many, many stores, close to 1,000 Walmart stores. So when a store says, we're out of toothpaste, we're out of dog food, and we're out of shampoo, and we're out of, chips. So a particular store sends in their order, and then this distribution center is in charge of building the pallet or multiple pallets to be delivered to that store in a truck. And so they have to get the goods out using those little robots that you saw. And then they have to build the pallet. And it used to be people would do this. These are very, very tall. They're much taller than I am, right? And they're very, it's like you have to carefully balance. So this is that process. This is really fun to watch in person. Hopefully you'll enjoy it. On the video, what it is 2 very large arms right here. 2, I think they're ABB arms. And there's products, what you see behind here is that wall, that vertical wall of robots moving boxes down dark hallways. They bring packages, and here we see what happens is that these robots then play Tetris. These robots get to play Tetris all day. They build these giant pallets, and you can see the pallets sort of shrinking as a new box arrives. It decides where to place the box. And then the entire pallet is then delivered on a forklift. So it's a very cool process. And then they shrink wrap it like this. So everything is automated. And there we go. They've finished. This was a very short video, but it's very, very cool to see this process of how it plays basically what I would call Tetris. It's really, really fun. Okay. So I've talked a lot about logistics. Let me take a break from let me summarize logistics, and then I'll move on. But this is really the big success story for robotics. For the last 15, 20 years, it has enabled all kind of globalization, customized orders and things like that. And what I've shown is kind of a range of technologies, and they sort of have different pros and cons, which are fairly obvious. Just want to point them out, right? That there's a lot more autonomy happening on this right side, right? That once you have an entire warehouse that's really customized, yeah, everything's very autonomous, but and it's actually very, very productive, but it's very relatively harder to integrate into your system, right? It requires a lot of change to the business, to the warehouse, and things like that. If you want minimal impact, but still a productivity boost, right? These types of systems, or these types of systems like the AMRs or the ARMs are much more easy to integrate. Now, again, I want to highlight that all the success stories are either navigation or arms, or what we call manipulation in robotics. We don't have many success stories that mix both. The only way we mix both is by building environments like this, where we can do both picking up things and transporting them at the same time. And we do that by really, well, I'm gonna leave it to you for a second. I'm gonna pause. What is the key to making this a success in both of those areas versus earlier technologies that can either only transport or only pick? and this is where it'd be much more fun to be in person, but the answer is structure. Like if you want to know, if you're thinking about whatever you work in, and you want to know, would robotics succeed there? Think about the environment, the problem you want to solve, and structure. Autonomy is facilitated by structure. We either, like the biggest success stories for today are either that we keep things really simple and the robot just has to navigate, like the top left, right? The warehouse structure, the warehouse layout is the structure. Or we start to put things in bins and make them all sort of the same size or shape or known shapes. Or if we want to deal with a more diverse set of products and things like that, we start to actually structure the environment. So there's really not a one-fits-all solution at the moment. We have to sacrifice something, but if we can have some sort of structure, then we can have things work. Now let me show you a few exceptions. I've talked about logistics a little bit too much, maybe, but that's like the big exciting, I think, success story. Let's talk a little bit about like outside of warehouses. There are success stories outside of warehouses. Hospital robots. We have an increasing number of hospital robots. By the way, this is the only robot I'm showing you right now that has wheels and an arm. It's a really fascinating story behind this company. It's Diligent Robotics, founded in 2015 here in the US. And they initially thought that they would use the arm to to fetch items from storerooms, get things off shelves or put items back on shelves for nurses and things like that. And after a couple of years of deployment, absolutely not. It didn't work. It's really hard to do what's called mobile manipulation, combining manipulation with a navigation platform. It remains a really challenging problem. And nurses were not happy with the results, and they actually didn't need that. What they needed was more effective transport across hospitals because they're walking such long distances every day to just take a sample to the lab or fetch some more bandages or whatever it is. And when they moved to that application, this is the only hospital robot I know of that has not gotten rid of its arm. They kept the arm because of all the many places they use it. They've used it about 10,000 times a month across all of their robots to do things like press elevator buttons or open doors, right? And the robot actually has a badge to open doors for when they're locked. So the arm is very useful. So I could talk more about it, but it's a great application. Several companies in this space. Home robotics, not a lot of success stories in the last 20 years. We're not going to talk about vacuum robots. That's obvious, but we have companion robots, for example, for older adults. And then we also have inventory robots for grocery stores, which were really explored during the pandemic, but are not quite as common as they could be. The technology just has not really paid off. Okay, so that's been, that was the 2000s, the early 2000s to mid 2000s. I want to now just finish up by talking about, the last few years and where we're going, sort of merging these current waves of innovation. And sort of how do we get beyond logistics into more unstructured environments? And if you pay attention to the news about robots, what you will have seen is something along the lines of humanoids, more humanoids. And at least in social media, LinkedIn, and other areas, we see a lot of talk about humanoids right now. And they're certainly taking a lot of VC funding. So let's talk about that first. It would be strange not to. Let me show you one of the coolest videos on humanoids. This is from Figure, which is, I think, 3 years old now as a company. And what they're showing here is something called Helix. It's a vision language action, a VLA model. So think about like an LLM, like a ChatGPT for robotic systems. So this is single machine learning model, right? Everything here is embodied AI, cutting edge stuff. Not so much about automation, but really pushing the AI capabilities of these systems. So this is a single model operating the system that combines perception, language understanding, and actual control.
Hey, figures, can you come here? Okay, I'd like to try something new. Even though this is the very first time that you've ever seen these items, I'd like you to use your new Helix AI and try to reason through where you think they belong in the scene, and then work together to put them away. Does that sound good?
Okay, and so this is a big jump. I don't know how many of you have seen this video. This is a big jump from the technologies I was just showing, right? Because I was trying to sort of prime all the challenges. There's physical challenges of just developing humanoids. Then there's the challenge of now we are doing mobile manipulation, which I sort of said is hard. And then we have ambiguous instructions here and a lot of reasoning and also multiple robots. This is a really cool demo. This is not a product, right? The difference between a product and a demo, but a very, very cool demo that is aiming towards this idea that's sort of at the forefront of a lot of people's minds, which is robot foundation models. Can we build the ChatGPT of robotics, right? What is it? What does that look like? What is it like to have a single AI model, a generalized AI model, right? That controls all kinds of different robots, simulated robots, real robots, underwater robots, logistics robots, to perform all kinds of tasks, right? And the idea is that this type of model would be like a brain. It would integrate not just language instruction, but camera data and sensor data from accelerometers and touch sensors and whatever else, and produce motion for all of these types of robots. And unsurprisingly, this is really hard. Really, really hard. So for the big jump to large language models that we've had in the last few years, we've been using billions of text examples and billions of image examples for vision and language models. We don't have the internet of robot motion. We've tried. There've been a couple of projects, one called RTX, that tries to combine data from 25 different research groups, all the data that they have. And even with that, it's not nearly enough, right? You get some cool results, but they're not anything I would run in a real world setting. And so the question is, where do we get, if we want the robot foundation model of the future, where do we get it? We can put robots out in the real world, right? So here are our options. We can put robots in the real world. Great. Very high quality of data. But the problem is it's going to be super slow and very costly. But China just opened a training center for robots in this way. They have an entire huge building where robots are just going to be learning and practicing and collecting data in this way. And then so there are definitely approaches to this. Simulation learning, right? We can learn lots and lots of data in simulation. This is so much cheaper. This is great, but our simulations aren't perfect. And that gap, what's called the sim to real, the gap between simulation and reality, is a huge problem. So it's like learning to cook in a video game, right? If you've played video games, if you have kids who play video games, learning to cook in video games, then someone gives you a real kitchen and says, okay, make dinner. The difference is very big, right? And the same for robotics. We can watch humans do it. You can watch humans perform tasks and learn from that. Very, very hard though, right? It's good data, but now you have to have humans demonstrate. Again, it becomes costly and not very slow to collect more data. You can learn from between different types of robots. If I have data on this robot, if this robot learned to cook, maybe this other robot learned to cook, but because the sensors are different and the physical body is different, it's actually a whole new challenge of how do you do what's called embodiment transfer. So the transfer between different shapes. So this is the big hurdle. This is where we are right now in 2025, is a lot of people talking about what does it look like for us to build a robot foundation model? Where do we get the data, and what are those challenges? But that's, I'll steal a couple more slides from this venture group that is a recent report from this month about kind of investment in actual European deep tech. It's a really cool report. Deal Room has it available online for free. You can look up. It's 180 pages or something. But I thought that they summarized very nicely where are we robotics as a field, right? Where are the big developments right now, right? Perception, which means sensing, cameras, touch, all that, still very much in a research problem. Learning, how do these robots learn? Simulation of robotic systems for better testing, generative AI, which I just talked about, LLMs and speech understanding, autonomy, of course. How do you integrate all this? I don't know why they separate two different types of learning. I think RL imitation learning is just a type of learning, but I'll go with that. And then of course we can't ignore the hardware. We're not done with hardware. I don't think hardware is the limiting factor for today's robots, but we still need better tactile sensing, better batteries, better improved power consumption, and just better hardware in general. So that's another thing. But that's where the current state of robotics really is. And if you look at just investment, this is not overall investment in robotics, but if you just look at investment in humanoids and foundation models for robot systems across the US, Europe, and Israel for the last few years, that's the big hype. That's what everyone is talking about. And it's in some ways draining resources, I would say, from other applications, unfortunately. In some sense, this is not a little bit of a bubble. We saw this with self-driving cars a few years ago, right? 5 years ago or so. So much excitement, so much kind of overhype, so much investment in self-driving cars, and then the bubble burst because we weren't able to get a product to market as quickly as some of these companies promised. And I think that's what we're about to see with humanoids. There's very much a bubble in this space. And you see this in the headlines, right? You see everyone wants to have kind of a little bit of this coolness factor. There's Mercedes will be using humanoids. Someone in Europe is doing so. I think BMW. And then here it is, figures. The figure ones, which I just showed you, the black robots are going to enter the workforce at BMW. And then you see other headlines. So these are headlines. Everyone wants a humanoid. But what they're going to be doing exactly is a little bit unclear because their motion is very slow, and the dexterity, those dexterous fingers that you see on those robots are actually make it really, really hard from a computational aspect to actually get robots to do anything. We have no idea how to control fingers particularly well. We know how to do things basically as claws, open, close. Dexterous fingers are just still not quite, and they break a lot. Are not quite mastered in the robotic space. So the question is, what are all these humanoids going to do? Right now, it's the next big wave, and it's going to happen. But if you're asking about today, 2025, I would say that most of these are right now hype. They put out really, really cool videos. They put out cool announcements about working with factories. but there's very few. I'm excluding from the hype one company, and that's Agility. And the reason I'm excluding them is because of this. You can go on the internet and find, oh, this is old. I forgot to update it. This is 2024. So great. It's a year ago, they were already putting up YouTube videos. This is roughly 6 hours of continuous operation of their humanoid robot in a actual business setting. Whoops. And we're back to structure, right? We're back to structure. This is another logistics kind of scenario. But you have in the background workers picking up these bins and moving them. And here they have Digit, the agile robot, picking up these boxes. If you pay attention to their configuration, they don't have fingers. They have little grippers, much more practical. They're a little much less actual humanoid. They look a little bit like crosses with insects, but for mechanical reasons, this is much better. So they're going for function over form. And as a result, they actually have a product that's being mass produced and mass deployed. And this video is very long, but it's like hours and hours and hours of operation. And they have many of these videos online. So there are success stories, but of course, it takes a lot of effort to sort of separate the hype from the reality for this type of cutting edge technology. So, big trends right now, of course, AI, machine learning, foundation model robotics, what I would call mobile manipulation is upcoming, right? The ability to navigate and put an arm on top, either as a humanoid or with wheels, is still up and coming. More cobots still up and coming. A lot of digital twins I didn't talk about, but a variant of simulation, right? All of these things are kind of where we are at right now. And if you want to learn more, I'll wrap up and take questions. If you want to learn more, there's a couple of really nice websites. The Robot Report, International Federation of Robotics. They synthesize and put out reports regularly. There are a couple of large events in the US. It's these two. Well, RoboBusiness is probably the biggest international one. This year it was in the US. This one was held just about a month ago. There's others, and I'm sure there's others in Europe. But these events, are the place where you can sort of meet a lot of people and learn more about these technologies. And with that, I will open it up to questions. I'm happy to discuss all kinds of different robots. And thank you for listening.
Thank you, Sonia. Thank you, Sonia. Okay.
Yeah.
Okay, here we are. And thank you so much for joining. And it's amazing. So I have here one question, and I think it's the question already. How do you think it's going to affect the use of robots to the employment?
That's a really important question, and we're all asking this question. And I think that the generative AI technology as a whole, so LLMs, ChatGPT, that type of model, is potentially going to affect jobs even more than robots. Robots will affect jobs. It's the next industrial revolution, right? So from when we developed the printing press and cotton mills and things like that. I think jobs will change. But at the same time, I don't think we can think of this as only in robotics, right? AI is driving this change constantly, and I see it in my job. I suspect many of you see it in your jobs. Anyone who writes sees it in their job, right? The scope of change is very hard to predict, and I think it is not as fast as people expect. But it will come. At the same time, when you talk to actual manufacturers, they talk about the challenge of getting workers to come and work at these factories. A lot of them, at least in the US and Asia, are sort of far out of the city where they can be big, take up a lot of land, and getting workers for them has been a challenge. I don't have an answer. I don't think anyone has an answer. Anyone who tells you they have the solution, I don't know if they do. But the answer is it's going to take jobs, but at some pace, and it's not overnight for sure. It's going to be the next 10, 15, 20 years.
Okay. And how far are we from having robots housekeepers?
Far. That is the hardest domain. So remember, I talked about structure. The one environment that has no structure is your home. Because your home, every single person here on this call has a very different home. And that's been a huge challenge for robots. And all these videos you see of humanoids going out and working in homes. Okay, what happens when it runs out of batteries? Or, we've all had our computer crash. Is this thing going to fall on your dog? Is it going to hurt your child, right? Like there's incredible challenges to actually getting this technology into households. So my research is actually on household robotics, and I spend a lot of time working on it, and it's going to be a while. I run a center on supporting older adults as they age, and we focus a lot on how do we help with physical tasks in the home, and we've unfortunately have a very long way to go until homes.
Okay. One more questions. Here, people are starting to join us for those kind of questions. What about robot maintenance?
Maintenance, that's a good one. And it's gotten pretty good overall. Obviously, things do break. And where did I hear that? So I heard this number. And now I remember I'm thinking, that I haven't signed any documents from this company. I was at a conference last week, and I heard all kinds of cool numbers. So one of these very big logistics warehouse automation companies that has, I'm not going to say which one, but it has many robots and operating in this kind of grid type scenario. A robot breaks every minute, roughly, if you have a large enough operation. And so for them, they overcome it with redundancy, lots and lots of robots. But they also have to have people sort of climb into that grid to get those robots out on a daily basis. So robots break. But the approach is build them in larger numbers, build them cheap, relatively cheap, and inexpensive sensors. So maintenance happens. I don't think, as far as I can tell, I don't run one of these companies, is it's not the most significant cost if you've done your engineering right. If you're a third party, just regular person, and you want to buy a cobot, cobots are really rugged. You can run a cobot for a few years and without major issues. So cobots are really solid. Just don't buy the first year product comes out. Don't be an early adopter. That would be my advice. I've made that mistake before.
Okay. And I have here another question, which is related to talent and education, a subject that we really care a lot here at the Bankinter Foundation of Innovation, because we have a program called Academia, where we try to train future generations on innovation trends. And do we need new engineering methods and universities courses to develop these robots?
Yes, I mean, many universities have courses, but I think what people are realizing is we need kind of like robotics for business courses and more of the user side of robotics. Not that there's the courses for engineering, and people go get a degree in mechanical engineering or electrical engineering or computer science. But what I think is a gap that we need is robotics and embodied AI as a technology, robotics for business, robotics for manufacturing. And that we are starting to see that. We also need what we in the US call continual learning, right? Or relearning. You already have a job, you're an adult, you're not a college student, but to come back and retrain to master this technology and to understand that technology. We are starting to see those kinds of courses in the US. I don't know how, but even here it's very small. And we need more certificate programs and other programs for adult education in that space.
Yeah. And are having a course at the States where you connect artificial intelligence with robotics?
Yes, there's so for the computers, so the computing degrees in a university are where AI is studied, and so almost pretty much any robotics class that's in the computing is always AI focused. So
Okay.
like every class I can think of that my department teaches on robotics, out of like 5 or 6 of them, they're all AI focused. So
Okay. I have here another one which is related to a previous one regarding jobs and employment.
sure.
And one of the attendees is asking what it is the relationship between jobs lost to robotics and jobs created by robotics.
That's a really good question, and I don't have a statistic on that right now, and I think it's going to change over time. Rodney Brooks, I know, has given talks about this in the past, and he might, I don't know. I don't know the number. There's definitely there are jobs created. Yes, of course. I think people highlight the imbalance between those jobs. In the case of Symbotic, I mentioned visiting their distribution center, and this is what they do is they retrain their workers. So people who used to lift the boxes themselves and unpack these boxes, they now operate the robots. So instead of firing people, they actually retrain them as robot operators on site. And I saw many of them working, and it's a much easier job physically, and they operate those big arms and the entire system overall. So I'm hoping that that's more of the future, right? Is that people are retrained on the job as operators, as in addition to the engineering jobs that are created to actually develop these systems.
Okay. Before we leave, I would like to know more about yourself. Why did you specialize in robotics and human-robot interaction?
I did not expect to do robotics. I had very different plans for myself when I was in college, but I took an AI class, and my instructor happened to be a roboticist teaching AI. And she's Portuguese, Manuela Veloso. And I got hooked. I got hooked on the idea that I could develop programs that were, could do things better than I can. And it actually, the robotics aspect was just fascinating to me, to have an effect on the physical world and to really help people. The people come in because to me, there is no fully autonomous robot. If you think about it, even the robots we send to Mars, or the robots that operate these warehouses, people are always in the mix. They're working for people, they're working with people. And to me, that connection is very important. And also from a research standing, it's just interesting because humans are the most unstructured parts of the world. We create the most chaos. And so it's also really interesting for me. Yeah, but I just really like the human impact as well. I work on, like as I said, with older adults as well, and helping them with all kinds of embodied AI technologies. We mostly work with smart homes in that setting, but we do work with robots, and the companionship and connection that they feel to robots is fascinating to me. It's very different than how, I see this technology. So that's also adds a very new perspective.
Okay, here have a last one. What could be your advice for short-term investment in what type of robotics?
Oh, certain investment. I would look at last mile delivery right now. So if you want, okay, it's so hard. Different people will tell you different things, right? But if I'm looking at, there's many technologies that are very, very early stage. The humanoids are very early stage. The bubble will pop. it will be another 10 years before this technology really matures. The same as we saw with that self-driving cars. If you're looking for something that's going to mature more quickly, sooner, I would say the next big thing is last mile delivery, which is that we have delivery with trucks, we have self-driving cars, but getting packages from that, self-driving truck or car or whatever to the final destination, that's called last mile delivery. And there I'm seeing a lot more mature companies and a lot of large companies investing in technology right now. It builds on our successes in navigation for the last few years, but tackles that last bit of unstructured, right? The real world. I think we're going to see a lot more in that space in the next 10 years. And to me, it's not as visually exciting as a humanoid, but I think it's a much more practical application. And yeah.
Okay.
In the US, Amazon employs 45,000 delivery drivers.
So I have another one here. I think this is the last one because he has raised his hand. So how do you see the use of robots as military weapons? Wow, it's a hard one.
Yes, that's I have very mixed feelings on that. Remember when I said robots are never fully autonomous? I hope that continues to be the case and that they do not become autonomous in that context ever. I mean, we've seen this with the war in Ukraine, with Ukraine using drones very, very effectively. I think there's an incredible power to autonomous boats, autonomous drones, autonomous vehicles, to hopefully save lives in the long term. But it's a very, very, very slippery situation, and I think it will create greater imbalances between countries who are more advanced with having more technology and being able to sort of dominate more easily. So I think it's a very concerning situation for me personally, as it should be